Hi class, so today we're going to learn how to add fractions. Super important skill that we got to learn. We're going to start this video off by actually determining our steps for solving, and then we're just going to do a couple of example problems. So, step one, you need to convert all terms. Now remember, a term is a number or value that's separated by an operation to improper fractions. Now, I know some of you have learned this in the past, but some of you might forget. So I'm going to put off to the side what it means to convert a term to an improper fraction. So what if you have a mixed number? Say you have 3 1/2. How do you convert that to a mixed number or an improper fraction? Well, your first step is to multiply whole number. In this case, that'd be 3 by denominator. Remember, your denominator is your bottom number, so in this case it'd be 2. So what I would do is I would do 3 times 2. That equals 6. Then what I do is I add my numerator, or in this case 1, to answer in first part. Well, what was my answer in my first part? 6. So what I do is I do 6 plus 1, and I get 7. Now, what is this 7? This 7 is my new numerator. So 3 1/2 is the same thing as 7 over, and I keep my original denominator. So it's a new numerator over OG denominator. Well, what was my OG denominator in this case? 2. So 3 1/2 is the same thing or equivalent to 7/2. So that's how we convert all terms to improper fractions. Well, after we convert all terms to improper fractions, now remember, this is only if necessary. So if they're already as fractions, basically in the form a over b, then you're good. You don't have to do anything. Okay? But if they're not, if they're like a mixed number, then we have to convert them. All right? After we do that, we have to determine or find a common denominator. Now, the way we find a common denominator is finding the least common multiple between our two denominators, which I'll go over in a second when we get an actual problem. This is also LCM in background knowledge if you don't know. If after me going through it quickly in this class is not enough for you, then that's your cue to go to your background knowledge folder and get a little more support on that. So once we have them all as improper fractions, and once we have found a common denominator, what we do is we rewrite expression over one common denominator. Then step 4, we operate and simplify. So those are our 4 steps. You convert all terms to improper fractions, you find a common denominator, you rewrite your expression over one common denominator, then you operate and simplify. So let's really determine what some of this means. All right, we're going to start our first example. Examples. So the first example is going to be -8/3 plus 5/6. So our first step is to make sure all numbers are in the form a of b. And if they're not, we make them in proper fractions to do so. In this case, I have -8/3 and 5/6. They are both in forms of A over B. I have one number over another. So I'm good. I don't have to do anything for step 1. Then what I have to do is find a common denominator. So I'm going to highlight my denominators right here. Excuse me for the yawn. What I notice is they are not alike, right? 3 does not equal 6. So they are not alike currently, right? 3 does not equal 6. So what we do is then we go off to the side and we list our multiples to find the common denominator. Now in class, we've reviewed multiples. Last unit, we reviewed multiples quite a bit. This would be a time to help pull out that multiplication chart if you need. But what we do is we put the bigger number on top, in this case it's 6, and the smaller number on bottom, 3. Those are my two denominators. And I start listing multiples. So what is the first multiple of 6? That's 1 times 6 or 6. What's the second multiple of 6? 2 times 6 or 12. What's the third multiple? 3 times 6 or 18. Fourth, 4 times 6 or 24. And fifth, 5 times 6 or 30, right? Multiples mean the number multiplied by whatever multiple you are. First multiple, multiply that number by 1. Second, multiply it by 2. All right. Usually approximately 5 multiples is enough. Now, in this case, we needed a lot less, and you'll get stronger at this as you go on. Some of you could probably instantly recognize the least common denominator. That's great. Then you don't have to do this step. Not a problem. However, sometimes we have to go more. Sometimes we have to go less if you can recognize it. And I'll show you why. Let's do my multiples of 3 now. I do the 1 times 3, which is 3, the first multiple of 3. 2 times 3, which is 6, or the second multiple of 3. 3 times 3, 9. 4 times 3, 12. And 5 times 3, 15. Now what I look to see if there's any in common. I see that 6 is in common and 12 is in common. What I want is the smallest one, though. The smallest one is 6. So if we notice, we actually only have to list 2 multiples of 3 to get a common multiple, and that's fine, right? That's why I say approximately 5. If you find a commonality right away, you can stop listing your second set of multiples. So in this case, our common denominator is 6. Okay. So what does that mean I need to do now? That means I need to make both fractions with the denominator of 6. If we notice, this fraction already has a denominator of 6, so I keep it the same, 5, 6. If we notice, this first fraction did not, though. So I have to think, what do I have to multiply my denominator by to get 6? Well, if you look over in your multiples, I notice that 6 is the second multiple of 3. That means I have to multiply the top and the bottom by 2. Because what is 3 times 2? Well, 3 times 2, and I'm going to bring my little arrow down, becomes 6. But since I did it to the bottom, I have to do it to the top. So what's -8 times 2? -16. So that's all step 2. You have to find a common denominator and then make your fractions with the common denominator. Now that I've done that, Now that I've done that, what I do is I write my fractions over a common denominator. This is a very small step, but important, and saves us some unnecessary errors. Because when I put them over the same common denominator, what I focus in on now is the numerators. And I use my normal rules. I ask myself, are they the same sign or opposite signs? In this case, they are the same sign. That was a big mistake. They are opposite signs, right? It's -16 and +5. Well, if they're opposite signs, we subtract, right? This is where my unit 1's coming in. So I do 16 minus 5. 16 minus 5 is 9. Nope, that's a lie. 16 minus 5 is 11. Sorry, and it's going to be negative 11 because negative 16 had the bigger weight. So now I operate. I had negative 11 over 6. Now the very last step I do is I see if I can simplify. Do these numbers have a common factor that I could simplify by? Like, do they both divide by 2? Do they both divide by 3? Do they both divide by 4? Then I do. In this case, 11 is prime, meaning nothing else can divide into it evenly. So my answer stays as negative 11/6. We can and should leave answers as improper fractions. So people think simplify means convert to a mixed number. That's not simplify, that's just converting. In this case, I don't need you to write this as negative 1 5/6. In fact, I prefer it as negative 11/6. It's easier for me to grade. The higher up you get in math, the more often you're going to leave them as improper fractions anyways. So let's stay them as improper fractions. Let's keep improper fractions and be comfortable with them. The only exception, there is one, of course, is if we're dealing with some word problems and it doesn't make sense to say negative 11/6 points deducted, right? It would be much easier in that case to say negative 1 5/6 points or something like that. So when word problems happen, it's usually better to convert them to mixed numbers, but otherwise we can leave them as improper fractions. All right, that was our first example. Let's go to our second example now. Whew, we did a lot in that one, so hopefully these ones will go a little bit faster now. I have negative 1 1/5 plus negative 2/7. All right. First step I have to do is convert all numbers to improper fractions. I see one number is okay. It's already in the form a over b. This number is not, though. So what am I focusing on? This number. I'm going to convert it to an improper fraction. Now, when we convert to improper fractions, we ignore negatives. So we ignore negatives. During conversion process. Super, super important. Because what people do is they say, oh, negative 1 times 5 gets me negative 5 plus 1. Well, if I use my rules, then that gets me negative 4. And this is not the correct method. It's not correct. So when we convert, we assume it's all positive. And if it started negative, it ends negative. I'll show you what I mean. So I'm going to do my conversion in the correct way with green. I'm going to do 1 times 5, because remember, I'm ignoring the negative right now while I'm converting, and that's 5. And then I do 5 plus 1, and that gets me 6. If we notice, 6 is not the same as negative 4, and that's okay. That becomes my new numerator. Now, my denominator was originally 5, so I keep it 5, so it's 6 over 5. Now, since it was negative 1 1/5, it's negative 6/5, right? If it started with a negative, I just tack on the negative at the end. Again, I don't worry about the negative in conversion. What I do is I remember it at the end. If it was negative, it stays negative, okay? All right, so now I have that plus negative 2/7. That's my first step done. Cool. Now I need to look for a common denominator. So I'm going to focus on my two denominators right now. If I notice they are not alike, so I do have to do my least common multiples off to the side. I list my 7 first, my 5 second, and I start listing. First multiple of 7, 7, 14, 21, 28, 35. And I'm going to stay there. I'm going to start with approximately 5. I can always add more. Now 5, 10, 15, 20, 25, and I start comparing. I look at my multiples up and down. I see 7 and 5, 14 and 10, 21, 15, 28, 20, 35, 25. I see no commonalities. So then I have to keep going. Well, I know that I'm really close on my bottom to getting a common. In this case, now that I've moved 5 times 6 was 30, 5 times 7 was 35. I see that 35 in this case is my least common multiple. Okay, so what do? I got to convert my original numbers. 7 times what gets me 35? Well, if I look, 35 is the fifth multiple of 7, so I got to multiply my top and bottom by 5. 5 times what gets me 35? Well, if I look at my multiples, 5 times 7 gets me 35. So I got to multiply by 7. What I get is I get 35 on the bottom for this first one, and 6 times 7 is 42. Remember to bring that down, that negative. Now the bottom here is 35. What is 5 times 2? It's negative 10 because again it was negative 2. Bring down that negative. Cool, I've got improper fractions that have a common denominator now. What do? I put them over one common denominator that we found, and then I focus just on my numerators, and I say, are they the same sign or are they opposite signs? In this case, they are the same sign. Remember, if they are the same, we just add them as if they're positive. What's 42 plus 10? 42 plus 10 is 52. Since they were both negative, it stays negative 52 and goes over 35. Now I look to see if I can simplify. This is even because it ends with a 2, so I know it divides by 2, but guess what? 35 doesn't divide by 2, right? In fact, nothing divides into 35 besides 7 and 5. And I know, looking at my multiplication chart, if I need to, that 7 doesn't go into 52 and 5 doesn't go into 52. So at this point, this is as simple as it can go, so I leave it. Negative 52 over 35. It's not a word problem. I don't need to simplify it, so I don't need to convert it to a mixed number. All right, let's look at example 3. Example 3, 4 plus negative 1 and 2/3. Again, my first step is to look and see if they're A over B. In this case, neither of them are. This isn't as A over B, and this isn't as A over B, so I've got to convert both. Now, how do I convert a whole number into a fraction? Well, I know some of you know this. What you would do is you would put that number over 1, because 4 divided by 1 is 4, so you can always rewrite an integer as a fraction by putting it over 1. Plus, now I got to convert this one off to the side. What's 1 times 3? 3 plus 2, 5. 5/3. And remember, since it was negative, it stays negative. Awesome. Now we have to look to see if we have a common denominator. We don't. Now in this case, I could list my multiples, but I know if this is 1 and this is 3, my least common denominator is going to be 3. So I can keep my negative 5/3. What I have to multiply this one by is 3. 3 times 1 is 3. 4 times 3 is 12. I have my common denominator. Now I write it all over that common denominator. I look at this. I see that they are opposite signs. Remember, opposite means subtract. So what is 12 minus 5? That is 7. Now you have to think, should it be positive or negative 7? In this case, it should be positive because the 12 has the bigger absolute value. My final answer is 7 over 3. 7's prime. It does not simplify any further. As you can see, once we start getting these steps, it goes quicker. All right, my last problem, I'm going to do number 4 right here since I have some room. 3 3/4 plus 4 1/3. I check, are they as improper fractions already in the form A over B? No. So I've got to convert both. 3 times 4 is 12, plus 3 is 15 over 4. 4 times 3 is 12, plus 1 is 13 over 3. All right, now I look at my common denominators. They are not common. Excuse me. I look at my denominators and they are not common. So I start listing my multiples. 4, 8, 12, 16, 20. Then I do 3, 6, 9, 12. I don't have to go further because what I see is 12 is the smallest common denominator. Awesome. So what does that mean I have to multiply 4 by? Well, 12 is the third multiple of 4, so I multiply it by 3. 12 is the fourth multiple of 3, so I multiply this one by 4. 15 times 3 is 45 over 12. I am now rewriting it, plus, 13 times 4, that's 52 over 12. Now, if you didn't know 13 times 4, that's why we learned how to do this last week, right? 12, carry the 1, 4, 5. Not last week, last unit. We learned how to long multiply again. No shame in doing this off to the side if you didn't know it. No shame whatsoever. In fact, I prefer to see the work. Now what I do is I put them all over one common denominator. I notice that the signs are the same. So that means I add the two numbers, 52 plus 45. I get 7, 9. So I get 97 over 12. That does not simplify further, so I am done. Come back to class. We'll practice a couple problems, especially ones where we will have to simplify in the end. Thank you.